Hi everyone, I am Raj Vijay, a lead engineer at Truechip Solution. Today we are going to discuss about the Truechip NoC Verification IP, in which we will cover NoC VIP's overview, introduction, features, and followed by the NoC VIP's automated integration using TrueI TBG, a testbench generation tool. So let's start with this. Today we discuss about the Truechip NoC Verification IP. Here is our agenda: introduction, VIP overview, top level architecture, VIP features, metric features, monitor features, scoreboard features, TrueI, test suites and coverage summary, VIP deliverables and VIP quality. Truechip introduction. We are leading provider of verification IP, silicon IP, automation and GUI and design services. We work in P3 framework, proven solution, perfect integration and prompt support. In India, we have R&D centers in Noida, Bangalore, Pune and Hyderabad. We are a team of 175 plus engineers and average experience of engineers is 6 plus years. We have global clients as in US, UK, Europe, China, Japan, Korea, Taiwan, India and Israel. We have verification IPs, silicon IPs, NoC silicon IP, mesh and crossbar type, GUI based debug tool, automation products. We are providing IP, SoC and ASIC, GLS, timing simulation related services. In other design service, we are also providing post silicon validation, RTL, PD and DFT service also. We have a TrueI tool which will help for debugging, integration, tracing, regression running and regression analysis, automated integration. Truechip NoC VIP is fully compliant with the latest bus protocol like AHB, APB, AXI, Tilink. VIP is available in Verilog, System Verilog and UVM. NoC VIP is compatible with Mentor Costa, Cadence NC and Excellium and Synopsys VCS Simulator. Truechip NoC VIP can be used in standalone NoC IP verification as well as NoC across the SoCs. This is VIP's top level architecture. As you can see here, n number of master and m number of slaves can be possible. VIP collect data from each interfaces and compare data for the data integrity checks across the NoC. These are VIP features. Any type of complex network topology can be possible. Even parallel and layered NoC is also supported by the NoC VIP. VIP has fully configured master and slave ports. Each master and slave port can be configured individually. NoC VIP has fully configurable memory map and segmented memory map slaves also possible. Transaction can be configured with the user defined value for each port. VIP checks data integrity across the NoC. Priority based transaction is also supported by the NoC VIP. As we already discussed, every interface can support a different protocol for master and slave ports. Apart from the different data width, VIP has different data width for other signals, like in AXI there is a user signal. VIP supports early response and transaction modification like merging and breaking as per the requirement. VIP support different phase shifted frequency for each master and slave ports. Address conversion is also possible by the NoC VIP. For the integration side, we have automated testbench generation using TrueI, which is very easy and efficient manner for integration of NoC VIP. For the performance side, we have bus utilization, throughput, latency in graphical as well as in tabular manner. Tracing is a very good feature of VIP through which user can debug transaction across the multiple node within SoC. Here are metric features. As we already discussed, like n number of master and m number of slave can be connected. Multi-level NoC is also possible. Configurable ports. Data width can be also different for each ports. Every port can support different type of protocol. Master port priority is also supported. Burst can modify as per the requirement, like incremental to fixed. Early response and interrupt generation in during the error response is also supported by the VIP. We support constraint randomization for protocol attributes like AW address, AWID, H address. We have a wide range of error injection scenarios. We support register access using UVM RAG model. In VIP, we have callbacks for user controllability. NoC monitor is easy to plug in and comply to the standard specification. Each master and slave port interface protocol checking is also available. Assertion checks is also there. Priority based transfer pass through the NoC is also checked by the NoC monitor. Monitor gives performance summary at the end of the test. Give error masking mechanism using automated error management system. It's like you can mask the error from the terminal by command line options. Apart from that, burst transaction detail in GUI and log file for easy debugging also provide, and summary of all the transaction at the end of simulation, like how many number of incrementing transfer is there, how many number of wrapping transfer will be there, how many number of fixed transfer, and in the tiling case put and get transfer, arithmetic transfers. In AHB we can say like undefined length, INCR 4, INCR 16, RAP 16. Each and every detail you will find at the end of the test. In monitor we have a functional coverage for bus interface. Each port has functional coverage for bus interface and configurations. We support callbacks for user configurability. Here is the scoreboard feature. So NoC scoreboard check data integrity across NoC as well as throughout the system. Any data mismatch between the NoC master and slave port will flash as an error. During write transfer, we'll check that NoC slave port data should match with the NoC master port data, and during read transfer also we'll check like read data received at the master port should be matched with the read data available at the slave port. And this data checking is independent of data width and protocols. Scoreboard has also easy error masking and mechanism using automated error management system. In Scoreboard also we have callbacks for user controllability. TrueEye. TrueEye is a debug tool which used for easy integration, debugging, searching, error detection and configurability. We discuss it about later. Test suits and coverage summary. We have total this type of test cases in our test suite, like basic test cases, random test case, error injection test cases, RAL based tests, dynamic test suits, assertion and cover point test cases. User can create their own test cases using our sequence. They can extend and create own sequences also, and their test cases also. VIP deliverables will provide the NoC monitor, scoreboard and metrics. Apart from that, we'll provide master and slave port VIP also. Test suits, integrated test bench example, TrueEye, test bench generation, tracing, performance and regression analyzer, integration guide, user manual, FAQ and release notes. These are VIP qualities. All VIPs come with a comprehensive set of assertions. VIP has extensive test suites and coverage plan. VIP has dedicated test suite to achieve 100% functional coverage and strong protocol checking monitor assertions. All VIPs are tested over industrial leading simulators. VIP are coded in System Verilog with UVM methodology, which makes it lightweight and easy for using. All VIPs are being used by the various customers, and we have a large set of error injection scenarios. About the engineer quality who developed this VIP has average experience of 5+ years, and each engineer can go through the specification to development of complete VIP. So here we have completed our Truechip NoC Verification IP introduction. Earlier we discussed about the Truechip NoC Verification IP. Here we discuss about the Truechip NoC Verification IP integration. This is our agenda: introduction, VIP overview, top level architecture, integration steps, change configuration. As we already discussed, VIP is fully compliant with the latest bus protocols like AXI, AHV, APB, tiling. VIP is available in System Verilog, Verilog and UVM. VIP is compliant with the Mentor, Costa, Cadence, NC and Excellium, Synopsys, VCS simulator. VIP is used in standalone NoC IP verification as well as within SoC. This is VIP's top level architecture. So n number of master and m number of slaves can be possible, and NoC VIP is connected with each master and slave ports. So now we will discuss how NoC VIP and master and slave VIP can connect with the NoC DUT. With 3 easy integration steps, user can fully integrate Truechip VIP in their test bench. Step 1 include top TB, DUT and VIP instantiation and port connection. Step 2 include VIP environment creation and component configuration in user test case. Step 3 include VIP environment variable setting and run script setting. As I said, in the top TB, user has already instantiated the DUT. So in parallel to that, user can also instantiate VIP and make the VIP and DUT connection with simply wires as shown in the slide. All the VIPs are parameterized with the top parameter macro, as each master and slave port data width can be different, so their signal width can also be different. For the top parameters, more details, please refer to the integration guide. There are two few signals like ENV ID and VIP type. ENV ID is number of environment or number of AXI, AHV or APB master or slave possible in the test bench. So how the number of AXI environment increase, that ENV ID will increase. For AXI it starts from 1, for the other VIPs it starts from 0. VIP type shows the VIP behavior, like if VIP is used as a master, user can set it as a 1, and if VIP is used as a slave, user can set it as a 2. So this step just include VIP top module instantiation and other protocol specific signal connection. In the second stage, user can include a test CFG file in their test case as shown, like each VIP has user file in their sim directory. and this user file includes TC VIP testcfg.sv files. This file has all VIP environment handles, config object handles. So after including these test config files, user can call some function in their base test build phase like tc NoC build phase, tc axi number of env equal to 4, and here basically we are setting total number of environment of axi, whether it's in master or slave. Here we have taken example for 2 master VIP and 2 slave, so that's why it's set for the 4. The same way for AHB and APB. For APB we have only 2 APB slaves, that's why. And at the end memory map configuration function. In the connect phase, user can call this function for connecting analysis port of the VIPs, and in the run phase they can call end test task for confirming all the transactions has been completed from the interface. Now step 3 includes environment variable and run script. Each VIP has 2 type of environment variable: VIP home sets where actual path of the VIP, and VIP user home. VIP contain user file directory in their same. User can copy this directory at your local end and make necessary change as per required for the integration. And user can set this VIP user home to that local path. For including the run script in user run script, user can directly add tc NoC compile list.f, or they can manually add each VIP compile list as same as shown in this slide. They can modify in these files as per requirement. For changing the configuration, as I already said, every VIP test CFG file includes VIP environment handle, environment configuration handle, and each component configuration handle. Using that handle, user can change the particular configuration in their base test or extended test. There are 2 methods of changing the configuration: after calling respective VIP's environment creation function, and in extended test after calling the super.build. In this slide basically we mention NoC VIP integration with their master and slave ports. For detail running in the particular mode, please refer to the integration guide and user manual provided by the release. So here we have completed the integration of NoC VIP in user test bench. So far we have discussed about the Truechip NoC Verification IP, and here we are going to discuss about the NoC VIP automated integration using TrueEye TBG. First of all, we need to open TrueEye from the terminal. TrueEye is a very useful tool from the Truechip which will help you for debugging, tracing, integration, regression analysis, performance analysis, and many more features. In this session, we are going to discuss about the automated integration. Integration type is new. VIP and DUT both we are going to integrate, and DUT type NoC. So here you can fill top file name, top module name, time scale, clock time period, initial value, whether it's a 0 or 1, duty cycle also you can provide from here, reset signal name, initial period, reset assertion period, active low, active high, reset deassert in which clock, that all. And here you can create on generate TB file. So TB file is generated here, as you can see. We'll click on OK. And going to the next step, On the second step is you can select DUT top file by simple browsing mechanism. Like here we select nocrtl.sv, and this you can pass compile file list if it is like here we are selecting SoC noc file.f. So here DUT and compile files are added. We can just check a compilation whether it's a clean or not while compile. So here all the environment will be grabbed by the Truechip, and default location is also set. You can obviously change it as per requirement. After doing this, we need to just confirm VIP protocols. In this step, tool will analyze which interfaces has been used as a DUT port. So here it detects like AHB3, APB, and AXI4. Going to the next step, here we have generated a block diagram. Like it has detected that two AXI master interfaces and two AHB interfaces. The same way in the slave side, two AXI interface, AHB and APB interface has been detected. You can see DUT signal names by clicking on this interface name for each and every one. Just confirm the DUT interface. Here you can manually drag and drop the VIP also, and within a one shot you can connect all VIPs. In this section, you can give the VIP path at your end. Now the AXI VIP, AHPPB, and AHP. So for this, like we have a NoC VIP, and there are AHB and AXI master and slave ports BFM also. So you need to select all of the VIPs. Now VIP connection has been done, so we can proceed, and block diagram is also confirmed. So block diagram created. Going to the next step. In this section, you can select the clock. If you have multiple clock, you can select from here. Also, you can create a new clock if you want some multiple frequency supported by the DUT, or some different phase shift is also there. So it's a clock mechanism. Like you can create a new clock 1, clock time period you can change, like it's a 5 nanosecond. So the same way you can change the any of the clock, and same for the reset. After this, at this point, we are going to connect VIP and DUT signals in our top. So here signal mapping is done. On the next step, you can see the signal TB files has been created. In the TB file, all the DUT instance and VIP instance connection has been added. We can check like top TB connection has been done properly or no. Like here we are going to check with the NC simulator. So here we are checking the top connections like DUT connection and VIP connection. As you can see, DUT and VIP signal mapping is very easy using the TBG. Otherwise, what in the conventional matter you need to do, like take a DUT instantiation, take VIP interface instance or a VIP wrapper instance, and take some wires and connect both of them and assign some values. Some you need to using interface or manually assign statement. So that user effort has been tried to reduce here. So we'll just wait for some time to be complete this simulation. So this is completed. Now we'll go for the test case creation part. Okay, so in this there is a memory map configuration. Here you can give a slave port start address and address. You can also provide, if segmented slave is there, you can provide a number of segments. Like if there are 3 segments, so you can provide high address, low address, and privileges for each segment. And you can also select the permission like restrict secured, restrict privilege, normal access for a slave as per the requirement. For the master also, you can select the permission like which level of access it can, like privilege or normal access, secured, whatever it's there. Also, we have master port priority. You can prioritize the master, like if there are 2 masters and there are 3 levels of priority. So you can provide a priority level. Suppose master 0 has highest priority, 1 and 2 has the priority 2, and master 3 has the lowest priority. So this way you can set the port priority also. One more feature of memory mapping is setup file. So you can load the configuration file if you have already existed some of the start address, low address or memory map configuration, and by you can load that file, and if you want to update in GUI, that is also possible, and you can save the configuration files. So just saving it, and so here we are at the test case generation. Base test will be already created by the TBG. Here we have 3 type of test case generation option: generate sanity test, generate dedicated test, and a full coverage test case. So generate sanity test will basically check the end-to-end checking and all the connections are done properly or no. In the generate dedicated test, you can create particular type of sequences or particular mode for each and every master. Like here we have, you can say, you can configure sequence for each of the master. Suppose for AXI, you can create a new sequence on this manner. Like here you can give inline constraint like length, size. Suppose here we are take a length 10 and burst as a 1. So after doing this, you can click on OK. So the sequence file has been already generated. This sequence will be used for running this. After completing it, you can also select from the existing sequence file or feature of the sequence. Like if I want to run some write sequence on AXI, so I will just select AXI write sequence. These are predefined sequence already coded by the VIP, like use existing sequence. Here we'll run AHB read sequence. Like you can create scenario like write from AXI, read from AHB, and write read from AHB, consecutive write read. So after clicking OK, all the test case will generate and you have to create on the generate test case file. The third option, we have the generate full coverage test cases. Here you can find all the feature related sequences and you can select whatever feature you required, and if you don't want, you can unselect it like this. Okay. You can also change the order, shuffle the sequences order as per your requirement, just for the randomization. We'll create here a sanity test for like here we are you can find the option like which master you want to run the sequence, which slave you want to run the sequence. Here we will select master 0 AXI and master 2 AHP, and for the slave side we'll select some AXI, AHP and APB. And if when you create on the create all cases, you can find whichever possible scenarios will be there, and here you will find with the attribute randomized value. If you want to manually change, that is also possible, or you can randomize from here every time. And parallel access is also there, like you want to access in multi-master scenario, if you want to start the sequences in a parallel manner on the two masters or no, that also you can decide from the parallel access. In the select test cases, we have the features like multi-master single slave, single master multi-slave, multi-master on slave boundary test, non-secured master, privilege access to normal slave, normal access to privilege slave, and all. So if you click on all, the all type of test cases we will generate. Here we are going to generate for the, we can generate all, while adding all the test cases will be generated while creating on the generate test case file. Here you can see the test cases file also generated. After clicking on OK, you can find a directory structure. Directory structure also you can visible on parallel to all the steps, like in top of the right hand. Here show directory structure. This will be created during the runtime. Like suppose on TB creation, TB directory will be generated at the DUT file selection DUT on the sequence and test. So this is our directory structure, like TB. You can see whatever files we have generated during the whole process. Test file also you can see from here. The same way sequence file. Here we have created AXI sequence. So the same way if you are creating AHB, APB, the run file contain compile list, run directory will compile list, DUT and VIP. So by clicking on the next, at this point we have two options, like you can run a single test case or run a regression. Test case you can select from the drop down menu which we have created earlier, and by clicking on the run test case, a test case running will be started. So you can, here we are going to run on NC simulator. So our test case running is started. As of now, we have seen like top TB creation, DUT and VIP instantiation, both of the connection, signal mapping, and creation of environment, test cases, and configuration of memory map. So all the things will be done using the TBG. Basically, these things take a lot time if you are going to create with a manual effort. So this is the main usage of Truechip TBG. So we'll just wait for to complete our test case. As you can see, compilation has been completed and test case running is started. This is our UVM topology, like all the VIP instances, versions, NoC VIP, and all has been created. So our test case run has been completed. You can see a test log by clicking on the view test log. So here is our full test log. As you can see, the other option here is to run regression. You can select the test cases, add or remove test cases which you have created by clicking on the generate regression list. Regression list will be created, and now we'll run the regression on. You can select parameters from here for the regression, like simulator, VIP, counts, and all other features like dump and debug mostly will take as a 0, cover will be 1, and at this will create a generate command. by clicking on the execute. Here you can select the server if you want to run the regression on some server, or here we are running on the local machine. You can browse the path to be run regression like TBG. So our regression has been started here. You can check from the terminal like our regression list has been created. So this is our regression log has started to be updated. So this way you can completely run test case and regression also. So here we are ending this window, and here our integration has been finished. So we'll click on the finish integration. Integration is successfully done. So here we showcase our NoC VIP's integration using TrueI TBG. So far we have discussed about the Truechip NoC Verification IP, its integration and automated integration using TrueI TBG. So now we are going to discuss about the NoC VIP extension, in which we will cover introduction, VIP overview, top level architecture, TrueI tracing, SoC Data Path Verification. As you already know, NoC VIP is fully compliant to the latest bus protocol like AXI, AHB, APB and TiLink. VIP is available in Verilog, System Verilog and UVM, and compliance to the Mentor Costa, Cadence NC and Excellium and Synopsys VCS simulator. NoC VIP can be used in standalone IP verification as well as NoC across the SoC. As you can see, our top level architecture, there are n number of masters and m number of slaves can be possible. As we already discussed, TrueI has a multiple features like debugging, analyzing, tracing, integration, and regression analysis, in which tracing is very useful feature where you can find the transactions origination, destination, and full transaction path across the NoC. Like in this diagram, you can see transaction has been started from the M0, passed to the NoC I0, and reaching at the slave S5. From S5, there will be a response going to the NoC, and after that, it's reaching at the M0. So it's independent of the protocol, like any type of masters or slave can be possible. So here you can find the full transaction path with each interface latency. After this, in SoC verification, you must have heard about the data path verification. Let's take an example. There is SoC like multiple cores, NoC, PCI NoC, DMA, bridge, SRAM, secondary NoC, MIPI NoC, and on-chip devices. It includes slow peripheral, high peripherals. So if one has to do data path verification for the DDR, so he must need to check like transaction started from, let's say, core 1 with address and data, whether this is properly passed through the main NoC, secondary NoC, and reaching at the DDR is properly or not with expected address and data. So for this, one need to put independent logic of scoreboarding or whatever their manually needs to do across the main NoC, secondary NoC, and many more things. These you can achieve using Truechip NoC Verification IP extension. As you can see in the slide, you can simply take single NoC VIP and connect them with each interfaces as shown. So this will give you the result like whatever transaction initiated from core 1 with particular address and data is reaching at the secondary NoC DDR interface, it's properly or no. Means data integrity is correct or no. So this is the first level of data checking. Suppose one is come to know that from core 1 to DDR, the data has been wrongly received. So what's after that? At which point the data has been corrupted? So for that also NoC VIP can be used. Like any SoC can be divided in the interface level like level 1, level 2 and level 3. So here one can put two NoC VIPs. First NoC VIP's master port is sampled from the level 1 interfaces and its slave port will sample from the level 2 interfaces. The same way NoC 2 master port samples from the level 2 interface and slave port sample from the level 3 interfaces. So here each and every level you will come to know that whether the data integrity has been matched or no. Like core 1 has sent transfer to main NoC and main NoC has sent transfer to the secondary NoC. So from core 1 interface and secondary NoC interface data has been matched properly or no. The same way main NoC has sent transaction to secondary NoC and secondary NoC has sent transaction to the DDR. So whether the secondary main NoC's data and secondary NoC DDR interface data has been properly matched or no. So this way at any point of SoC you can find the data integrity using Truechip VIP extension. So here we have completed Truechip NoC VIP extension. Thank you.